Hey there everyone, ready for another video? So this one here will be the learning module about estimation and inference. Important statistic concepts here. Again, my comments before we start, since the advent of machine learning, big data analysis start being incorporated into the CFA exams, we've seen more of the concepts related to statistics applied to machine learning and big data projects being asked as content for the exam. Okay, that's what I believe it happens here on this module, estimation in inference, which was not a separate module before. It was, like I said, it was included in other topics. Now it has its own learning module, right? Estimation in inference. So I believe that, again, with higher probability than previous exams, the topics related to estimation and inference may be a question on your exam with higher probability. All right, so that's it. So let's try to understand what is important here. What are the learning outcomes? What are the key points? Some examples. All right, I'm just right off the bat. Just remember, estimation and inference. It's related to sampling. I need the right sample. I cannot have a biased sample. We cannot have that data mining, data snooping. None of those problems that some kind of samples could give it to the financial analyst, right? So the sample has to be unbiased. It has to be like a way that we can use, and then the answers we get from that sampling estimation we made are more close to accurate or have some kind of statistical meaning. That's the idea. Okay. Again, not a long topic, like I mentioned before. There will be quantitative methods modules that will be longer than the others. For example, linear regression hypothesis testing. It usually takes, there's a lot of things to cover. Now, estimation and inference, portfolio mathematics, right? Those are less. Probability trees, they're very specific. So some of those videos are going to have an hour more. Some of those will have less. Okay, that's the case here. I do not believe we're going to need a long video to cover estimation and inference. Okay, well, let's go. Let's go to the slides, learning objectives, key points, and then the points that I made, which I believe that's worth it to pay attention, because could become, or higher probability to become questions, become questions in the exam, I meant. All right, friends, let's see. First one. First learning outcome is compare and contrast random or simple random, stratified, cluster convenience, and judgmental sampling. So I want to know here is to compare and contrast. So in other words, if you have a table in front of you with all those methods, right? Stratify, random sampling, clustering, sampling, right? Convenience sampling, judgmental sampling. That's in one column. In the second column, right? All the points, right? Pros and cons, if you may, but characteristics of each one, so you can really get it, right? In case one of those appears in the exam. I can totally see a question, for example, a multiple choice, three very, very short questions, alternatives, like which of the following is a, most likely is a advantage of the clustering over the judgmental sampling, right? So any type of questions regarding definitions, so in this case would be compare and contrast, could appear in the exam, because that's what the learning outcome is telling you here. Second one, explain the central limit theorem and its importance. It's an easy theorem to explain. I don't know if we could say that it's a, a theorem that you can always use because it never fails, because there's a lot of assumptions behind this theorem. However, it's important to know what it is and why it's important for the financial analyst. We're talking about our colleagues, our financial analysts, our colleagues that do research. Those are the ones they're going to need to be very aware of how to sample to come up with the projections on the answers, right? Conclusions that they try to study. Right, and last one, Describe the use of resampling. So again, one thing is sampling, the other one is resampling. Sampling, we have stratified and cluster. Those are the most important ones we need to see here. Stratified sampling or stratified random sampling, and the clustering or the cluster sampling. That's for a population. Then if you have a sample already and you want to resample, then you're going to use bootstrap and jackknife as a way to do some estimations. Okay. All right. Let's see what else. Next slide here is the key points. So let's see the key points here. So the methods of sampling, the simple random sampling, which is super simple. Right? It's a simple random sampling. Just go there and randomly choose the elements of your sample. Okay. The simple random sampling. Well, what's the problem here? You could have bias here. For example, you just select, out of a population of 100 elements, you just select the first 10. It's a random sampling, but it's not it's not like shuffling your cards properly. Let's say. Okay. Stratified random sample, it's better, more used, you need to know, okay? And you need to know how to perform this. That's more chances to be a question in the exam. Cluster sampling as well. What is the difference between stratified random and cluster sampling? Make sure you know the difference, okay? How to perform. I think an image will be better here, so I have it further down, an image to show what is clustering, what is stratified random, so you can kind of like get the difference. It's not difficult. I can almost promise you that to you. Now, non-probability sampling, well, those are the ones that are more like on the judgmental type of sampling. I believe this, and this should be included. Right? Sampling from different distributions. That's the central limit. That's the beginning to start the central limit theorem. What is the central limit theorem? It says that if I remove a sample from a population, and we could care less how this population distribution is, could be skewed, could have kurtosis, could be like, completely out of shape distribution. If you take a sample out of it, right, and this sample is sufficiently large, you can infer that this sample is normal distributed. And then you can make some inferences about that using probability distributions, a distribution of probability. So if I assume that that sample is normal, then I can use the normal distribution. Now, I'm going to mention here something important related to prerequisites. So normal distribution or probability distribution should be a prerequisite here, right? You need to know what is a probability distribution. And I'll explain here very simple, in a simple way, but I think will do the job here. So imagine that you already have tables constructed for you, made by fellow colleagues or people that work in statistics, right? They create those distributions for you. So if I'm able to identify something that I'm studying, and I can say, look, that sample, or that population that I'm studying, it behaves as a normal distribution. It behaves as a T distribution. It behaves as a distribution. Then I can use whatever my colleagues in the past already calculated for me to use to predict things about that population and that sample. That's the idea. So if you're able to include a population or a sample in a particular distribution, could be a log normal distribution, could be a normal distribution, could be a t-student distribution, then you can use those probability distribution, the tables, the studies that were made on those distributions to apply for your sample into your population. That's why it's important that you're certified, or that you guarantee, or that you have some kind of certainty that population, that sample has a particular distribution, that you can then use the findings about that distribution to apply whatever you studying about your population or sample. Okay? All right. So that's important to have in mind. So now you don't need, for the exam, for the CFA exam, you're not going to need to know the tables, the normal distribution table. Oh my God, if it is a critical value of 1.3, right? What is the probability, right, that of that value be on the distribution, right? Or even calculate the critical value based on degrees of freedom, right, and distance from the standard deviation to the mean, etc. I think that's out of the scope. Okay, in real life, Excel does that for us. We don't have you're not going to have the luxury to use Excel in your exam, not yet, maybe in the future, I don't know. Okay, but right now, I would say don't worry about memorizing how to find critical values and probabilities under probability distribution. No, just understand what they mean. What are they for? Why we created those distributions? Okay, all right. And the last two here, the standard error or the sample mean, that's something that you must know. Okay, standard error is not standard deviation. Standard error is usually for a sample. Right? Standard deviation usually for a population. However, sometimes we use this interchangeably. However, think about, for the exam purpose, to make your life a little easier here, if I'm talking about standard error, I'm talking about a sample. If I'm talking about standard deviation, I might be talking about a whole population. Okay? All right. So the standard error is the standard deviation of a sample. Let's put it this way. Or, if it's the standard deviation of a sample, logically should be the standard deviation of the population divided by the number of observations, more or less, right? Well, that's the logic behind the standard error. You think about variance. Think about the variance of a population. The variance, okay? How do I calculate the standard deviation of the population from the variance? I'll do the square root. Square root of the variance of the population equals the standard deviation of the population. Well, think about that now. If I take the variance of the population and divide it by n, okay, I have the variance of the sample. And if I take the square root of the variance divided by the square root of n, I have the standard error. So the standard error is the square root of the variance divided by the square root of the observations. Okay, we're going to use n, not n minus 1 here. Okay, we're going to use n. Again, what I said, look, I want to kind of be very clear here with you, especially those that are studying mathematics and statistics, and you probably know that I'm not saying exactly the definition how it's supposed to be. What I'm saying here are ways for you to make the connection to answer a CFA exam question. I'm not teaching you statistics here, okay? I'm teaching you what you need to know to answer QM questions for the CFA exam. Okay, that I want to be very clear here, because of course I'm saying here something here that's a professor of statistics. Hold on a second, it's not like that. Yeah, I know, but if I'm going to be too specific here, I'm going to lose focus. You're going to lose motivation, and you're going to be out of the type of questions that you would face in the exam. We're looking for questions that takes maximum minute and a half to be answered. Okay, we're not looking for tricky questions, because we know the CFA exam does not ask you tricky questions. So we're looking for knowledge, right? That's what you need to know. You need to understand. I'm giving you not much the explanation of the behind the scenes, but I'm giving you ways, strategies, or way of looking, so you can make the associations, the necessary associations that you need to be able to answer those questions in the exam. That's the idea here. All right, there you go, in bootstrapping and the jackknife on sampling distributions. Okay, we're going to be doing that. Bootstrapping and empirical sampling distribution. All right, those are the learning outcomes and the key points, friends, that we gonna address here now on my notes related to the learning module estimation and inference. Okay, making some inference about something. All right, so let's go to my points, the ones that I have here written for you. There you go. So Here's learning module 7. Oh, there you go. But you know, if you're not taking the exam in 2024, you might be taking the exam in 2025, and this is still material for 2025. It may not be learning module 7, right? For future videos, I'm not going to even put the learning module number anymore. But if you're watching this video in 2025 and you see the same video as last year, right? Is because the topic has not changed. The maximum has changed for us to keep the video here is if you changed the order. So instead of learning module 7 on the exam of 2025, estimation and inference will be learning module 8. Well, but if the content is the same, the video will be the same. Just, you know, kind of clarifying for those. I had received some messages about that. Good. So learning outcomes I already did. The key points I already did. So this one here is just for those watching the video. If you want to take a picture or a screenshot of the image that you see here, go ahead. Okay. But now let's go to the points that I want to cover now. Explain sampling methods, random sampling, stratify random, cluster, and the non-probability sampling, which is, I believe here is going to be a conceptual question, right? Which of the following are the pros and or which are the cons, or which one's most likely, least likely related to judgmental probability, or judgmental sampling? Convenient sampling. What is the problem with having convenient sampling, right? Convenient sampling is what is more convenient data available. That's the one you take. Which kind of problems do you think this is going to cause on your thesis, huh? On your what you're trying to find? Okay. So those are the problems with non-probability sampling. If you go over the questions on the ecosystem, you will see that there are few questions about judgmental probability, judgmental sampling, convenience sampling. Then you can get some ideas how those questions would appear. I'm not going to spend much time on those. I'm going to focus on the ones above here. Okay, friends, first one here, explain sampling from different distributions, which has to do with the central limit theorem. I have a little image here for you, which in my opinion will do the job here. So think with me. You have a population. You have no clue how this population is the distribution. You don't know if it's normal. You don't know if it's skewed, if it has kurtosis, or if it has this crazy shape here, right? Like look like the demand curve for a product right there, right? This one. That's the first rectangle here. Okay, or square if you may. This is called the population with a strongly skewed distribution. That's fine. That's the population. We don't care how the population is distributed because you want to take a sample out of that population. So look what I'm doing. We're going to do now. We're going to take two elements out of this population. And then you're going to see the shape distribution of those two elements, the two observations, which is the second rectangle here. Look at that. It kind of like gets the bump, right? That little bump that we want. We always wanted that bump. Because that bump, that top, it means that, well, we have a center, which is the average, and more or less, all the expected numbers are around that central expectation. Right? Unless, well, very few are outside. That's what we want, because if we have that, if we have all my observations are very close to the expected value, I have very little variation, that's good. Right? Well, anyway, but two elements of a sample, it's not that great. I need more, right? We need the rule of thumb is like 30, but we don't need to memorize that. So let's take more. Now, look at the third square here. I have 10 observations, friends. 10 observations, thinking out of that population. Look at the shape. It's a little bit more close to the bell curve. And then the last one, where you have 25 observations, we get something that's more, very close to the normal distribution. That's the idea of the central limit theorem, that it doesn't matter how the population is. If you remove a sample out of it, you can assume, look, the word is assumption, you can assume that the sample is normal distributed. And therefore, you can apply the normal distribution concept to create some expectations about that population using the sample of the population. Okay, that's the central limit theorem. So it could be in the exam Okay, for some reason, I think the CFA Institute likes this central limit theorem because it's present in several, it has not changed that topic for ages. So since when I took the exam, the central limit theorem was a topic that we need to learn, okay? And there was several mock exams that ask questions about that. So I could, not using the word here, I could infer that some of the exams, level 1, 2024, will have questions related to the central limit theorem. Once again, I always want to remind you this. How many exams do you think the CFA Institute have to create for level 1, right? For a particular window, like say February or August or May or November, right? Well, think. We need at least 3 for the entire world. 1 for the folks in the Australian area, folks like Central Europe, folks in the Americas, right? Otherwise, the person that finished the exam there in Australia can give a phone call to a friend in Los Angeles. In Los Angeles, the person not even ready for that. The exam is going to be next day, and then tell, hey, listen, my exam, I seen this, and this. You know, you're not supposed to do that. You know, we sign a pledge, you have all those things, but you know, what human beings do in privacy, it's kind of hard to infer that was a violation. You're not supposed to do that, right? I actually, for all of my students, I extremely cautious you not to tell me which questions you've seen in the exam. I don't want to know, okay? Because I want to protect the integrity of the exam. That's one of my jobs as part of the CFA prep, exam prep provider, right? So don't even try, with all the good intentions, I know, I don't want to know the questions that you've seen in your exam. But this could happen. To avoid that, we're going to create different exams for let's say 3 different exams. Now, you have 5 days of exams, so we need 3 times 5. But during those 5 days, we have 2 exams per day. So we have to multiply that by 2. And we need February, we need May, August, and November. So now multiply all this and see how many different unique exams you need per year. Right? And if you want to create different unique exams, you're going to need probably to include everything that we've seen on the lessons as questions in the exam. That's it. Okay? That's how it's going to be. All right. Continuing here. Explain now the standard error or the sample mean. Then I put here the formula. That's super important for you to remember. Standard error equals standard deviation of the population divided, right, by the square root of n. Okay, square root of n. Now, where is the square root coming from? Well, the square root's coming from the variance, right? What is standard deviation? Is the square root of variance. So if I had put here on the numerator variance, and then I do square root of the variance divided by the square root of n, is the same thing as doing standard deviation divided by square root of n. Okay, so try to memorize the formula of the standard error. Don't confuse the standard error with the coefficient of variation. The coefficient of variation that you saw on the previous video. Good, that's the standard error. Where are you going to use the standard error? Well, most likely you're going to use the standard error on a confidence interval, which we're going to be talking about in a future video. But what is a confidence interval? Is you have an expected value. And then you want to know how much you expect that value to deviate in real life from the expectation. So I expect 10% return, but it could be between 0 and 20. Right? 0 and 20, my 10% is right in the middle. That's an interval, 0 and 20. But that interval could be smaller, right? That interval could be 5 to 15 instead of 0 to 20. My interval, 0 to 20, is smaller, right? 5 to 15. My average is still in the middle. Or even better, an interval between 9 and 11. 9%, 11%, right? With 99% of certainty. That's great. So you have a tiny interval, meaning with 90% of certainty, you could expect returns between 9% and 11%, but most likely you're going to get 10%. That's a confidence interval. Now, the larger the confidence you want, right? If I want to, instead of 99%, I want a 90%. I want a less confidence. Then my interval is small. If I want more confidence, my interval is large. So now the confidence level, more confidence, more interval. What about standard error? Well, standard error also influences on the size of the interval. So the larger the error, the larger the interval. Because instead of between 9 and 11, then I'm going to have that 0 and 20. So if I have an interval 0 and 20, that's an interval that allows more errors. If I expect 10, but I get 1% or I get 19%, those are deviations. But if I expect 10% and then I get 9, 9.5, 9.8, 10.3, it's all around my expectation. That's great. Right? So try to now, we're going to talk about this in another video, future video, but try to put in your mind now, what is a confidence interval and what makes the interval to be larger or smaller. For example, typical questions I've seen mock exams before. If you increase the sample size, what could happen most likely with your confidence interval? Answer, more sample size, more predictability, lower errors, lower interval. Okay, so again, try to understand when the standard error will have an impact in which type of questions would you face related to the standard error. All right, friends, let's continue here. For the stars of the learning module that we're talking about here, estimation and inference, which are the sampling methods, sampling and resampling method. So look at, I have here bootstrapping and empirical sampling distribution. Okay, bootstrap, empirical sampling distribution. So those are process, right? Techniques that you follow, a recipe, if you may, to do sampling and resampling. So let's start with resampling, bootstrapping and jackknife. Okay, I put here some of the key elements of it. So bootstrap, we already seen on the previous video, has been shown to be an excellent estimate, etc. But it's, look at this is important. It's not a good choice, or not a good choice, for dependent data, missing data, censoring, or data with a lot of outliers. So there you go. There could be a question here. Which of the following is an example of that represents bootstrapping not being a good choice for resampling? When? And then it could put one of those three there. Okay? All right. However, it's an excellent method to estimate many distribution statistics because you can do a lot from a small sample. Right? So that's the good thing about bootstrap. You can use a tiny sample to make it more out of it. But on the other hand, if that sample has outliers, if that sample is not, good, then you're going to have problems doing resampling with that. All right. Another characteristic that you see the bootstrapping is the replacement, remember? So if you go back to the previous video, then you're going to know how to do the bootstrapping, right? What is that? You have to take a number, then put it back, take it down, then you keep doing this, do the average, right? And then you can construct a sample, a new sample. Now, jackknife, right? It's you cannot do you don't do with replacement. So it's like works by subsequently deleting one observation in the data set, and then recompute the desired statistic. So that's the same, the one without replace. I take that one, but I don't replace it into the sample. Okay, so it's simpler than the bootstrapping. There's more order. So those are the characteristics. That's the pros, the positive points about the jackknife style. Right? The main application for the jackknife is to reduce bias and evaluate the variance of an estimation. So in other words, is to reduce the bias that the bootstrapping could cause. Okay? Jackknife and bootstrap, it's for resampling. So go over, make sure you can get as much out of this. Pros, cons, when to use it, right? Why is used, etc. All right. So look at that. Look what I put here, some kind of steps, because we already seen this. But look at that. Bootstrapping. Randomly select a sample with replacement from a data set. Okay? Steps, right? Calculate the mean of each resampled data, as we seen on the previous video. Okay? And then you create a sample with those averages. Okay? So I take the number 5. Let's say I have five numbers on my sample. Right? Number 1, 2, 3, 4, and 5. Then I take one. Took the number 1, put it back. Took number 1 again, put it back. Oh, took number 1 again, put it back. Then I took number 2, then I took number 3. Okay, add those numbers divided by 5, that's the average. Do it again, do it again, do it again, and then all of those averages become now your sample. Okay? Now, jackknife. You're gonna leave out one observation at a time from the original data set. Okay, that's the main premise. Steps. Calculate the average return for the entire data set return, and for each observation in the data set, recalculate the average return by excluding a observation. You see that they're very similar, but one is without replacement and the other one is with replacement. Try to get the characteristics. Imagine how questions could be created related to them. How can a bootstrapping question be in my exam? How a jackknife question could be on my exam? How a stratify random question would be on my exam? All right, now let's talk about the stratified random cluster. And like I said to you, the non-probability sampling, the more subjective sampling, that I leave up to you. Kind of take a look on the questions on the ecosystem and then a little bit on the lessons. But this one here does not deserve much time to spend on it, at least in my opinion. But stratify random and the cluster sampling, it's important to know the difference. So ask yourself, do I know the difference between stratify random sampling and cluster sampling? Do I know similarities, contrast and compare? That was the learning outcome. Well, that's what we're going to be doing now. Couple of things to talk about. Stratified and cluster. Be careful with the word cluster, because cluster sampling is one thing, and clustering for machine learning, which is an algorithm that you teach, that you give the machine to classify things, it's another thing. So clustering, that you're not gonna see much on level 1, clustering for machine learning, but you're gonna definitely see on level 2, cluster. Right? It's a unsupervised algorithm that we use for machines to classify things for us. That's called cluster method. Right? Here is cluster sampling. Okay, so not to confuse that definition. All right, you know what? Let me show you an image. I think an image is gonna be worse than those words here. There you go. Create a little image here for you. Okay, there you go. Put a little bit more. Perfect. Take a look. Okay, take a look now and see if you can understand what I wrote here. Right? Like here I have my samples. 1, 2, 3, 4, 5, 6. Right? Here I have the cluster, and here I have stratified. Okay? So what do? I go to a population and I create clusters from that population. Or I stratify that population. In any event, take groups out of that population. Okay? So for example, I want to study professions in a particular town. I want to see the level up, which type of jobs we have there. So I go there and I classify, right? I take all the police officers, okay, all the police officers, and I take all the doctors, not physicians. I'll take all the teachers, professors. I take like sales, and I divide it in those what I call small samples or subpopulations. Great, subpopulation. Now, look what I can do. I can go to each one of those populations, the police officers, the doctors, the teachers, the retailers, anyone, and then I'll take 1 or 2 or 3 elements of each one of those groups, which is here on the stratified. Take a look. The stratified are dividing those groups. Look at that. Okay, like that. There you go. And then I selected 3, I could select 4, could select 1 of each one of those subsamples, and then I create my sample. There you go. That's stratify random. Okay. Now clustering is a little different. They follow the same logic, but it's a little bit different. On cluster, I divided in groups. So I mix up the teachers with the professor. I mixed up, everybody's mixed. And then I divided them in groups. And then I select the whole subgroup to be part of my sample. See? So here in this example, I selected the cluster 1, 4, and 6 to create my sample. On the stratified, I took a little bit of each one to create my sample, but in the end, I would have the same number of elements on my sample. Okay, so here should be written subsamples instead of sample. I just didn't have enough space. So subsamples 1, 2, 3, 4, 5, and 6, and you can do clustering or you can do stratification randomly. Okay, so I think that's, I mean, at least I believe that this is not difficult for you to grasp, to remember. Like clustering, get those images, and I think it should be good. Now, the question is not going to be like that in the exam, right? The question is going to be probably like, well, explain the difference or similarity. Which one of those are difference or similarities of clustering, stratified random sampling, or similarities between bootstrap and jackknife, or the difference between stratified random and the bootstrapping. So again, that's the type of knowledge you need here, right, for the questions that you will face. That's it. That's it, friends. Next, the next learning module is going to be hypothesis testing. That one will be a longer video. Hypothesis test, there's a lot to talk about. All right, let's do the usual here. Let's take a look on the learning outcomes to see if I cover all the key points, and then we finish the video. All right, contrast, random, stratify, cluster, convenience, and judgmental. I did that. Sampling. Explain the central limit theorem and the importance. I already did that. And describe resampling, bootstrap, jackknife. Oh, done. So all the learning outcomes are taken care. The key points. Sampling methods. Yeah. Random sampling, stratify, cluster. Non-probability or judgmental or subjective sampling. Central limit. Standard error. We explain. And the bootstrapping. Oh, check, 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 check. I like check marks all over the place. Okay. I guess that's good. Perfect. I hope it was useful. I hope you got something out of the video to help you understand the material. Right? Try to do the questions in the end of the chapter, right? If you have the book, or in the ecosystem, if you have access to it. Try to do that. Do with the answers, right? Look at the answers. Okay. You don't need to challenge yourself, because when you take a look at the question and already you look at the answer and the explanation, you save time. You can cover more questions in a shorter amount of time, and you can also get a lot of explanation, so you study at the same time. I always want to have the mindset when you approach a question in the ecosystem, on the official mock exam, you imagine that question will not be in the exam. Boom. But a similar question most likely could be in the exam. Then do this method. Read the question, read the answer, and then imagine how that question could be reformulated, redo it, not redone, created differently, so it would be in the exam. Okay, friends? Well, that's it for this video. I hope it was, like I said, good, entertaining. I hope I was able to help you to grasp better those concepts, right? And I'm going to stop right here. Bye-bye.